As with rational numbers, a rational expression is undefined if the denominator is 0. If we replace a number for the variable which makes that denominator 0, we say that the rational expression is undefined for this value of the variable. So we have a rational function here, x squared plus 7 over x minus 8. And we find that if x equals 8, that's going to make this denominator 0. Therefore, the domain can be written in interval notation as negative 8 to 8, and then pick back up again at 8 to infinity. So what this says is every real number except for 8. And you can see that because there's no bracket here. It's an open parenthesis, which means 8 is not included. So this interval is basically from negative infinity to positive infinity, but it breaks it up at 8 to show you that 8 is the only number which is not included. We can also write this domain in set notation. So we start set notation with the squiggly bar, and it says that the set, that's what that notation means, the set of x, and then this bar means such that x is a real number and x not equal to 8. Or you could just put a comma there instead of and. Either way, it means the same thing. So it reads the set of x such that x is a real number and x is not equal to 8. Let's write the domain of each of these rational functions in set notation now. So our first example here, g of x is 4x cubed minus 3x over 2. So I'm basically looking at the denominator only, and I want to see where this equals 0. 2 will never equal 0, right? There's no variable to solve for, so that means that the domain is the set of x such that x is a real number. And I'll just write a number like that to make it shorter. There's no restrictions. X can be any real number, and this function will be defined. For example B, h of x is 3 minus x over x squared minus 4. So I'm only looking at the denominator here. And I want to say, where does this denominator not equal 0? So we're going to solve this like a quadratic equation. It is. And so I need to completely factor the other side. Since I've got 0 on one side, I'm going to completely factor the other side. And there's two terms. This is a difference of two terms, and they are perfect squares, right? That's x squared, so x times x, and 2 squared, so 2 times 2. And since it is a difference, that means that these are different signs, and that's why there's only 2 terms in the polynomial and not 3. So then each of those factors I'm going to set not equal to 0 by the zero product property. So then if I opposite that number term from both sides, I'm going to find x is not equal to negative 2 and x is not equal to positive 2. So the domain is the set of x such that x is a real number and x is not equal to negative 2 or positive 2. Close it up. For example, C, f of x is 5x plus 4 over x squared minus 3x minus 10. So I'm only interested in the denominator here because the numerator can be any real number for x and it's still defined and it's fine, but I can't divide by 0. So x squared minus 3x minus 10 cannot be 0. So since I have 0 on one side, I just need to factor the other side, and it is 3 terms. The first term is a perfect square, but the last term is not. So this can't be a perfect square trinomial, but x squared can only be factors of x times x. And 10 can have different factors. It could be 10 times 1 or 5 times 2. I'm thinking probably 5 times 2. That way I might get a 3. So different signs. And the bigger number is negative, so 5 is bigger. And if we multiply that across, we've got a negative 5x plus 2x. That does add to the middle term, negative 3x. So we've got factors of x minus 5 and x plus 2 here. If we go across, right? So then each of those factors set not equal to 0 by the zero product property. And that's just going to change the signs there. So this is going to be a positive 5, and that's going to be a negative 2. So the domain is the set of x such that x is a real number, and x is not equal to, and I'll put the negative 2 first because it's the lowest, and close it up. So that will be the domain. X is a real number and not equal to negative 2 or 5.